Okay, so in our last class, we discussed about the nomenclature, synthesis, and reactions of pyrazole, imidazole, and also we discussed about the synthesis and reactions of oxazole and isoxazole. So now let's look into the thiazole and isothiazole. So what is thiazole? Thiazole means it is uh, a heteroatom, more particularly sulfur and nitrogen containing a five-membered ring. Okay, sulfur and nitrogen containing a five-membered ring, more particularly at 1 and 3 position, is called thiazole. So, if we are looking into the preparation or synthesis, how one can synthesize a thiazole? So, it is possible to synthesize thiazole starting with the chloroacetaldehyde. So, what is chloroacetaldehyde? More particularly, alpha position. This is the functional group, and this position is called alpha. Alpha chloroacetaldehyde. Alpha chloroacetaldehyde, when it is treated with the thioformamide. I think you are aware about formamide. Formamide means CHONH2 is called formamide. So in place of oxygen, if the oxygen is replaced with the sulfur, then it is called thioformamide. So that means reaction of chloroacetaldehyde with the thioformamide undergoes condensation reaction and gives rise to thiazole. If we are looking into the mechanistic part, so you know that thioamide means thioformamide, it will be equilibrium with the amide enol form. That means one of the uh, hydrogen attached to the nitrogen, it will come and form a bond with the sulfur. That means there will be a double bond here, and this double bond disappears and converted into SH. That is called amide thiol form. Similarly, here, once the SH is formed, SH, it will form a new bond with this carbon, and chlorine and H, okay, chlorine and H will go out as a HCl. And you know that one of the proton present here, okay, one of the proton present here, it will go, it will form a bond here, and a proton will move from this carbon to this oxygen. Then also it's called as keto-enol tautomerism. So that keto-enol tautomerism, once the keto-enol tautomerism is obtained, there will be a removal of H and OH formed here. So that is how that is how there is a removal of water and forming a thiazole. So here removal of water, removal of HCl is happening, and a condensation reaction. These are byproducts, right? And here, so this is one method of preparation of thiazole. That means chloroacetaldehyde, more particularly alpha chloroacetaldehyde, when it is react with thioformamide, it undergoes condensation reaction and gives rise to thiazole. Similarly, it is suppose in place of thioformamide, if we are taking thiourea, then you will get a substituted 2 amino substituted thiazole. So what is the difference between thioamide and thiourea? Only the substituent NH2. In place of H, NH2 is there. So that is the reason here substituent NH2 is there. Then the obtained amino thiazole, more particularly 2 amino thiazole, when it undergoes diazotization followed by treating with boric acid, the diazotization NH2 is converted into N2Cl, and this process is called diazotization. So once the N2Cl is obtained, if it is treated with boric acid, there will be a replacement of N2Cl with H. Then the obtained one is called thiazole. So that means, so thiazole is also possible to prepare with chloroformaldehyde, alpha chloroacetaldehyde, and thiourea. It undergoes a condensation reaction and gives rise to 2 amino substituted 2 amino thiazole. This obtained to 2-amino-thiazole, when it is subjected to diazotization, it gives uh, thiazole. At second position, diazonium chloride is obtained. This diazonium chloride, thiazole diazonium chloride, on treatment with boric acid, gives rise to thiazole. And one more method of preparation, second method of preparation of thiazole is starting with N-acyl. This is called N, and this group is called acyl. And where N is present to this carbonyl group, alpha. This position is called alpha, and this complete group is called acetamido. Okay, alpha acetamido ketone. Name of this compound is called, this position is alpha and this is a amido, acetamido. So alpha acetamido ketone. Alpha acetamido ketone, when it is subjected to phosphorus pentoxide, so what will happen? Phosphorus pentasulfide, what will happen? So the you know that this carbonyl group is hamide carbonyl group, and this ketone is uh, a carbonyl carbonyl carbon, but this carbonyl is a amide carbonyl and this is a ketone. So this oxygen is replaced with sulfur. So that's what obtained. Okay, a sulfur is obtained. Once the sulfur is obtained, then what will happen? There will be a removal of proton. So where and all the proton? This is one proton, and here one proton, and this oxygen will go out and forming a 2 comma 4 disubstituted thiazole. So let's look into the uh, let's go to the next slide. So here I'm discussing about the uh, reactions, more particularly electrophilic substitution reaction. And thiazole undergoes electrophilic substitution at fifth position. This position is called fifth position. How it is fifth position? You have to numbering starting with the sulfur. 1, 2, 3, 4, 5. Fifth position is the electron rich, and electrophile will attack the fifth position of the thiazole. And here I am taking a sulfonation. Sulfonation means addition of SO3H to the fifth position of the thiazole. So volume is the source of sulfonium ion. What is sulfonium ion? SO3H is the SO3H plus is the sulfonium ion. What is volume? Volume is a mixture of sulfuric acid and sulfur trioxide. So when thiazole is treated with helium, it form a thiazole 5 sulfonic acid. Similarly, when it comes to the bromination, so bromination means what is happening here? A bromine source. What is bromine source? Bromine in acetic acid. So here bromonium ion attacks the fifth position of the thiazole and gives rise to uh, 5-bromo thiazole as the product. Similarly, uh, a bromine in carbon tetrachloride. Carbon means chloroform. So chloroform is a solvent. Here the acetic acid is the solvent and here chloroform is the solvent. So bromine is a liquid. So what will happen when 2-hydroxy 4-methyl thiazole is undergoes bromination in presence of chloroform, gives 5-bromo, uh, 5-bromo, 2-hydroxy 4-methyl thiazole as the product. So here in this slide I am explained about how the thiazole undergoes sulfonation and bromination. So with this I will go to the next slide. Next, next I'm this is again a one question framed. Okay, so predict the product and write the mechanism. So up to this, including this equation, is the question. So for that, how you can answer? So you know that this is a hamide. This is a hamide. Hamide usually it will be in equilibrium with hamide enol. So there is a double bond here. So there is no NH. There is a double bond. So that means this proton is moved from nitrogen to oxygen. That means here there is a double bond and OH. So once the OH is formed, this OH react with the phosphorus chloride. How it will react? The lone pair present on the oxygen can attack uh, phosphorus and chlorine will go out. So once there is a chlorine is going out, there will be an intermediate formation like this. At this moment, this bond pair will go over here, and this chlorine along with this bond pair, it's attack the second position. So here the living group is phosphorus oxychloride and the product is 2-chlorothiazole. So this is the how you can answer the above question. So in this, the product is 2-chlorothiazole, and this is a representation how the 2-chlorothiazole is obtained. So with this, I will go to the few more reactions of thiazole. So this is again a nitration. So what here the nitrating mixture is used. Nitrating mixture means HNO3 and H2SO4. Here what is happening? Nitronium ion is generating. The obtained nitronium ion, uh, it's an electrophile and it attacks the fifth position of the thiazole. So that is the reason obtained compound is 5-nitro-thiazole. So one more source of nitronium ion is N2O4 in presence of trifluoroborane. So and this reaction occurs at 70 degree, and also it also occurs at 40, but 70 degree the rate will be more, and the 86% product is formed. So what is happening here? Nitration. So more particularly, the fifth position of thiazole, 2-methyl thiazole, is attacked by nitronium ion and giving rise to uh, 2-methyl 5-nitro-thiazole as the product. So with this, I think we discussed about the preparation and nitration. Okay, we also discussed about the sulfonation of thiazole and bromination of thiazole. So let's look into the few other reactions of thiazole. So more particularly, nucleophilic substitution reactions. So reactions involving the side chain deprotonation. That means this is a side chain. So this side chain deprotonation, removal of proton. Once the proton is removed, there will be a formation of anion. So removal of this proton is possible with a base called N-butyl lithium. So what will happen? N-butyl lithium. Okay. So butane picks up this proton and going out as a gas, N-butane. N-butane is a gas, it will go out. And lithium will sit here and forms an anion. So that anion, that's what I have written here. That anion react with an electrophile. What is electrophile? Methyl is an electrophile. What is the source of methyl electrophile? Methyl iodide is a source of methyl electrophile. So methyl means methano, what you call carbonium ion. So that means this anion form a bond with this methyl and iodine will go out. Iodine along with this lithium, lithium iodide is a living group, and alkylation occurs at the side chain of the thiazole. So this is about how the uh, alkylation or nucleophilic substitution side chain which is present to a thiazole ring. Suppose a thiazole is subjected to dissolved metal reduction. So dissolved metal reduction, the reagent is sodium in ethanol. So in this, sodium will act as a source of electron. Sodium gives one electron to the substrate, and sodium converted into a Na plus. And after taking this electron, thiazole, once if it is taking here, what it will do? So this bond pair will sit on this nitrogen, and that bond pair picks up a proton from the ethanol. So that means initially there will be a formation of NH. So later on, uh, what will happen? Then you know that there is a one electron here. So this electron So now the double bond is reduced into a single bond. One electron is here. So one more electron it picks up from the sodium metal, and there will be a bond formation called CH2. Later on, so there will be a this sulfur and methyl group cleavage. How the sulfur and methyl group cleavage? Sodium, if it gives electron to this carbon, this bond pair will sit on sulfur, and that bond pair picks up a proton from the ethanol, converted into SH, and this one electron again picks up an electron from the sodium and converted into NHCH3. So this is how the mechanism I explained, how the thiazole is cleaved and converted into NCH3 and SH in thiol. Okay, this is about the reduction of thiazole. So with this, so up to this, we discussed about what is uh, thiazole, how the thiazole is synthesized, and how the what are the different methods for the preparation or synthesis of thiazole, and also we discussed about what happens when the thiazole is subjected to electrophilic substitution reactions such as bromination, nitration, sulfonation. Okay, and also we discussed about nucleophilic substitution, more particularly at the side chain of the thiazole. We also discussed about the reduction of thiazole, how the thiazole is converted, ring openings uh, happens when it is treated with sodium in ethanol. So with this, I will go to the next one. Next one, what is the name of the compound? Isothiazole. What is the difference between the isothiazole and thiazole? So thiazole means sulfur and nitrogen are at 1 and 3 position. Suppose sulfur and nitrogen are at 1 and 2 position, then it is said to be thiazole. So this is the thiazole. So means isothiazole. Isothiazole means in a 5-membered ring, if the sulfur and the nitrogen are at 1 and 2 position, then it is said to be isothiazole. So how the isothiazole one can synthesize or prepare? So it is possible to synthesize isothiazole starting with the propene. Propene is a gas. Ammonia. Ammonia is also a gas. Sulfur dioxide. It is also a gas. So that means it's a gaseous reactions. So that means when propene, ammonia, and sulfur dioxide is passed through a heat on the heated alumina, so we will get a isothiazole as the product. And how this is formed? Maybe there will be a reaction. How the reaction? So these two, nitrogen as well as sulfur, will form a bond with this carbon as well as this carbon, and giving rise to isothiazole as the product. So this is one method of preparation of isothiazole. So that means propane reacts with ammonia and sulfur dioxide in presence of alumina on heating to give isothiazole. So one more method is there. What is that method? Propargyl aldehyde. So the propargyl aldehyde means C triple bond C CHO is called propargyl aldehyde. The propargyl aldehyde, when it is treated with sodium persulfate, so what will happen? There will be a new bond formation between this sulfur and this carbon. So that's what. Once there is a new bond formation between this sulfur and this carbon, this bond pair picks up a sodium, and this is what the intermediate is obtained. So once there is a formation of this intermediate, when it is treated with liquor ammonia, so that means this ammonia, it will form a bond with this sulfur, and also it will form a double bond with this carbon. Oxygen and H2 will go out as a water and forming isothiazole. So these are the two methods of preparation of isothiazole. One is with propane, ammonia, and sulfur dioxide. Other is with propargyl aldehyde and sodium persulfate. So with this, I will go to the next slide. Next slide will give you the information about reactions of isothiazole. So isothiazole, when it is subjected to sulfonation, So it will give you the electrophile. What is electrophile here? Sulfonium ion. What is sulfonium ion? SO3H is the SO3H plus is the sulfonium ion. And you know that in thiazole, fifth position is the position where there is a electrophile attack. Whereas in the isothiazole, the electrophile attacks at the fourth position. Okay, so electrophile attacks at the fourth position because the fourth position is the more electron density one. So that means isothiazole, when it is treated with oleum, as I mentioned, oleum is nothing but a combination of sulfuric acid and sulfur trioxide. And oleum will act as a source of SO3H plus. So that a sulfonium ion attacks the fourth position of isothiazole and giving rise to isothiazole 4 sulfonic acid. Isothiazole 4 sulfonic acid. Similarly, when it is subjected to bromination. So bromination means a bromide, okay, bromonium ion is added to the thiazole ring, where it will add more particularly at the fourth position. So that means thiazole undergoes bromination at fourth position and giving rise to 4-bromo isothiazole. Similarly, when it is subjected to nitration, so nitration means nitronium ion, okay, will attack the fourth position of the isothiazole and giving rise to 4-nitro isothiazole as the product. Okay, so this is about what is called as isothiazole. So we discussed up to this uh, what is thiazole and how the thiazole is prepared, what is and what are the electrophilic substitution reaction and reduction reaction. Similarly, we also discussed about what is isothiazole, how it is synthesized, and what are the electrophilic substitution reactions. So now I will move to the another heterocyclic moiety that's called synthesis of coumarins. What is coumarins? Coumarins is nothing but a benzo fused. So what is the name of this compound? This is called pyranone. Okay, so this is a six-membered ring with oxygen as a heteroatom. Then it is called pyrane. Suppose a ketone group is attached at the second position, then it is called pyrane 2-one. A benzo-fused pyrane 2-one is called the coumarin. Uh, this is the general structure of coumarin and how the coumarin is prepared. And this synthesis of coumarin is given by the scientist called Peachman. Okay, so what is happening here? You know that what is this is one active methylene compound. What is the name of this compound? This group is called ethyl group, and this group is called aceto group. Ethyl acetoacetate. This group is acetate. So ethyl acetoacetate. This is one active methylene group. So here, uh, uh, so ethyl acetoacetate, when it is treated with resarsenol, so what is happening? There will be a new bond formation, more particularly this carbon and this carbon. There will be a new bond formation between this carbon and this carbon. Once there is a bond formation, how the bond formation, the pi electron present in the benzene ring, it will form a bond to this carbon. Once there is a new bond formation, this carbon attains a positive charge. Then there will be a removal of this proton and regeneration of aromaticity. So once there is a new bond formation between this carbon and this carbon C double bond O is converted into OH. Once there is a OH is formed, so there will be removal of proton from this carbon and there will be a formation of double bond. So it's a condensation reaction, removal of water. How the water is removed? One proton from here, one proton from here, and oxygen will go out as a water and giving rise to a key intermediate like this. And this key intermediate also, on heating, what will happen? The lone pair or the bond pair can react with this carbonyl carbon and ethoxy will go out. And that is how a coumarin structure is obtained. It's a substituted one. Where what are the substituent? Hydroxy and methyl groups are the substituent. So 5 hydroxy 4 methyl coumarin is the product. Okay. So what is the difference between this coumarin and this coumarin? So this is an hydroxy coumarin and this is a hydroxy methyl coumarin. That's only the difference. Then what are the reactant? Sorry, sarsenal is same, but what are the difference between these two? So this is a ethyl acetoacetate, and what is this? It's a name. This group CHO group is called formyl, and this one is called acetic acid. Formyl acetic acid is the reactant. So as I mentioned earlier, there will be a new bond formation between this carbon and this carbon. Once there is a new bond formation between this carbon attains a positive charge and there will be a removal of proton and there will be a double bond formation and there will be a regeneration of benzene. Similarly, once there is a new bond formation between this carbon, this double bond is converted into OH. Once the OH is formed, there will be a removal of proton from here, water is going out, and there will be a double bond formation like this. So that is what the intermediate I have written. So now, at this moment, if this compound is heated, okay, so what will happen? H and OH, removal of water, so giving rise to 5-hydroxy coumarin as the product. So this is about how the coumarin is a heterocyclic compound. More particularly, it's a bicyclic compound. More particularly, it is a benzofused pyranone pyranone compound. So with this, I will go to the next slide. Next slide will give you the information about uh, a second method of preparation of coumarin. So coumarin, how it is prepared, okay, starting with the salicylaldehyde. Again, it's a name reaction. Okay. So what will happen when salicylaldehyde? Salicylaldehyde means hydroxybenzoaldehyde. Hydroxybenzoaldehyde. Orthohydroxybenzoaldehyde is called a salicylaldehyde. So salicylaldehyde, if it is reflexed with acetic anhydride, AC2O is called acetic anhydride. So what is acetic anhydride? CH3CO, O, CO, CH3 is called acetic anhydride in the presence of sodium acetate. It's a base. So what is the role of base? So it will create an anion. Where it will create? CH3. Okay, the proton removed from the acetic anhydride create an anion. That anion attacks this carbon. Why it is attacking this carbon? Because this carbon is electron deficient. So then what will happen? There will be a OH formation. OH and H will go out as a water, and that means there will be a new bond formation between the acetic anhydride, CH3 of the acetic anhydride, and this carbonyl carbon. So then the lone pair or the bond pair attacks the carbonyl carbon, giving rise to coumarin as the product. So this is a reaction, and I am explained how the aldehyde react with the acetic anhydride and the role of acetic sodium acetate and how the coumarin is formed. But now I will go for a mechanistic pathway how the salicylaldehyde is converted into coumarin that I am explaining in the next slide. So this is the one. So this is the structure of acetic anhydride. So instead of writing CH3, I have written as a CH2 and H. So this H is taken by the sodium acetate. So that means sodium will sit over here and this proton is taken by acetate anion and converted into acetic acid. So now the sodium acetic anhydride is formed. So this anion attack the electron deficient carbonyl carbon and then OH and H is going out as a water molecule. This is a NaOH is the living group, and there will be an intermediate formation like this. Now the lone pair or the bond pair will attack this electron deficient, and this bond pair means acetate is acetate. While going acetate, it picks up this proton and going out as a acetic acid, and gives rise to coumarin as the product. So this is the mechanistic pathway how the salicylaldehyde on treatment with acetic anhydride in presence of sodium acetate gives coumarin as the product. So in the next slide, I am explaining how the uh, instead of taking acetic anhydride, it is also possible to take equivalent. So what is the equivalent? This is the one, active methylene compound. So this is again a question. So question in the sense, what is called as predict the product and explain the mechanism. What is the name of this compound? This compound name is, this is the ethyl group, and this group is called aceto group. So ethyl aceto acetate is the name of the reactant. So ethyl aceto acetate, when it is treated with a substituted salicylaldehyde. So what is substituted? Bromo is substituted. Okay, bromo is substituted salicylaldehyde, and here piperidine is used as a base, and this reaction is carried out at 0 to 10 degree centigrade. Here there is a question mark, so you need to write what is the product. So if you want to know the product, then what you need to do? You need to know what is the role of piperidine, and also you need to know what is the structure of piperidine. So this is the one. Piperidine means, so in a six-membered ring, if nitrogen is present as a heteroatom, then it is called piperidine, and piperidine is a saturated cyclic compound. There is no unsaturation in the six-membered ring. So what is the role of piperidine? Piperidine capture a proton. So more particularly a methylene carbon. So this carbon is called methylene carbon. This carbon is called active methylene carbon, and this proton is acidic nature. Why this is acidic in nature? Because this carbon and this proton is attached to a two electron deficient carbon. This is also electron deficient carbon. This is also a electron deficient carbon. That is the reason uh, this carbon and this proton is acidic in nature. This carbon is active carbon. This proton is acidic proton. So with mild organic base, it is possible to capture this proton. Once the proton is captured, there is a formation of anion. Okay, that's what I have written here. So once the anion is formed, this anion can attack this electron deficient carbon. Then what will happen? Removal of one more proton, and uh, O is going out. So a double bond is formed like this. Once there is a double bond formation, and this oxygen means lone pair or the bond pair can react with this carbon, and ethanol. Okay, ethoxy, while going, it will take up this proton. Ethanol is the byproduct and giving rise to a substituted coumarin. So today we discussed about the reactions, more particularly synthesis reactions of thiazole and isothiazole. We also discussed about the what is called as coumarin. Okay, so what is coumarin? What how the coumarin is synthesized? More particularly, we discussed from Peachman method of synthesis, and also we discussed how the salicylaldehyde and acetic anhydride is converted into coumarin. Similarly, we also discussed about the substituted coumarin synthesis. So maybe at this position, I will stop. Maybe in the next class, I will continue the remaining one. Okay.